How's it going? So I mainly I've been helping John and Ryan work on the plow, but I've also been mainly focusing on the back portion that holds the bucket to actually dig up the gravel once the topsoil's been pushed out of the way. Um, the past year seemed to work pretty well with just a couple exceptions, so the design I have right now is probably going to be pretty similar, which I'll go over that for those of you who are new. Basically, you got a gear motor here attached to a big gearbox, and it rotates to the small gear here, which rotates the bigger gear here, and then there's the shaft along here. It's connected to these two arms, and these two arms hold a bucket, which is not displayed here. But it's pretty simple. Just have a rotary shaft that pivots to the bucket on the end, lift up and down. Super simple. Uh, in past Zach said to use it last year. Last year we had to take apart basically the sides of the robot, take the treads off and everything to get the uprights off and get to the shaft, which was causing a ton of issues. It was almost impossible to take the thing apart without spending like an hour doing so. So aiming to improve upon that. And then also there were some issues with fasteners, so gonna solve those as well this year. But really, there's not any huge changes. Some of the changes that we will be going about, hopefully, if we end up doing this. Whoops. So the uprights, the thing in blue that holds the shaft in place, it's gonna be a little shorter and lighter because the bottom point. This is not working. The bottom point is going to be raised up because the motor for the suspension will slide down underneath, so it needs to be higher up than it was last year. So the entire upright therefore is shorter, so it'll be lighter. This hole here will be countersunk and unthreaded, whereas last year it was just a regular hole with threads, and that also caused some issues. Not really a big change there. The biggest change is that the top will be removable. I'm going to cut it off here and then have it be bolted into place with two screws. And the reason for that is because that will make it so that if we make it so the tops of either uprights can come out, then we can make it so you can lift the entire rotational shaft off much more easily instead of having to pull the uprights off to the sides. So we can do maintenance and such on the shaft much more easily. Otherwise, it's pretty much the same shaft, just half-inch carbon steel, pretty good amount of rotational stress it can handle. Yeah, I did increase the size of the gear on the shaft on Spacey over Tracy to add additional strength, but we can see about that. Yeah. That's another reason why I want to downsize, because if I can just use a big ass gear on the shaft, then don't need that powerful motor anyway, right? So another change I've been working on is there was a piece like sort of fixing the distance between the shaft up here and the motor down here, because on Tracy a long time ago found that when we put the motor in place and put the gears up together, the gears would tend to push away from each other and like not interlock. So our solution to that was to have a plate water jet cut to fix that distance so the teeth can push away from each other. But so what I did for this new design is modify that plate so that instead of being water jet cut, it would actually be machined. So it's more than just a plate, it's like several just like custom pieces. As I said before, the uprights have caps that are removable, so you can take the shaft off. Now the piece that fixes the distance between the motor and the shaft would also have a removable top piece. And then there'd be a second piece down here, which is cut in half, like straight across the center of the motor. And then a third piece on the bottom that joins the motor to the supporting bar underneath to like just hold it up and support the motor's weight. So basically, it would be super easy to take this assembly of three pieces apart. Whereas before you'd have to take the uprights off and stuff to get the whole motor off, which was a pain in the butt. So, the gear right here was kind of in the way of removing the screws for that attached to the motor. You don't necessarily have to cut this part in half here, but the biggest thing is the end cap. I'm not sure if I actually do want to cut the bottom piece in half as well, but it's just an option that we have. The limit switch mount is on the side of one of the uprights. It's got 3 limit switches inside to tell the electronics in the robot when the bucket is down all the way, and then when it's level, and then when it's all the way up and ready to dump, so that the computer can stop the bucket from turning when it gets to its top and bottom points. This is just like a 3D printed thing that basically holds the limit switches. The limit switches like mount in these two kind of like semicircular slots, and you can tighten them in place, or you can loosen them and then slide them around. How it works is there's basically, it's not in this picture, but there's like a cam here that rotates around and triggers each switch as it goes past to tell the computer, hey, this is tripped, so stop rotating the motor. This is how it looked in Spacey. I'm not really probably going to do any huge changes to it just because it seemed to work really well. One thing I will do is just kind of modify the cover, the dust cover for it, because that's a little bit hard to take on and off, kind of awkward, and it doesn't stay in place very well. And then, again, it's kind of hard to see in this picture, but basically and this is like what it looks like without the dust cover on it, but on the back side that you can't see, that's the side that actually goes against the upright, and that's also where the heads of the screws are that you tighten and loosen to adjust the positions of the limit switches. So you basically have to take this entire blue thing off to actually change the location of the limit switches, and that's kind of annoying. So I want to figure out a way to make so you can tighten and loosen the limit switches and adjust them without having to take the entire thing off the robot. But that's not really a huge change. That's just more of a convenience change than a like structural change. So this worked pretty well. Not going to change much else about it. I don't know if that was a super clear explanation of how it works. Does anyone have any questions? Okay, the slide is screwed up. This should say arms up here. But these are the arms that lift the bucket. These are going to be pretty similar to last year as well, with a couple of changes. First of all, the only thing holding them in place last year, okay, first of all, for those of you who are new, the bucket just slides onto these two curved pieces, and it can be moved up and down if you tighten bolts in. Most of you should know that by now. But anyway, these curved beams are held onto these straight beams by two brackets on spacey, and those didn't work very well. So we're going to probably make those stronger by using either like reinforced brackets that we machine ourselves, or some kind of like extra beam to make like a, I don't know, triangular sort of, yeah. If you put a cross beam here and make like a brace, I guess. So it would be like, but anyway, the biggest thing is just making the arms a little stronger, where they have to support the most weight so they can't bend around like this on their joint. And then, though we don't seem to have any issues with them bending around here though, so we're going to make them a little lighter by using 20mm aluminum instead of 30. I still need to do an FEA on that, but I don't think that'll be an issue. But yeah, otherwise the arms are pretty straightforward.